Welcome to the FD Hurka Metrology channel. Today, we are covering something that affects manufacturers more often than they realize: the setup mistakes that quietly undermine the accuracy of video measurement systems. Let's walk through what they are, why they happen, and exactly what to do instead. What is a vision measurement system, and how does it work? A vision measurement system combines a high-resolution camera, precision stage, adjustable lighting, and measurement software to capture detailed images of a part and calculate precise dimensional data from those images, measuring without ever physically touching the part, which makes it especially valuable for small, delicate, or high feature count components with complex two-dimensional profiles. Why do setup conditions matter so much in non-contact optical measurement? Unlike contact tools that measure what they physically touch, a vision measurement machine measures what the camera sees and what the software interprets, which means the optical path, the environment, and the calibration state of the system all become part of the measurement, and getting any one of them wrong will produce wrong numbers. What is the most common setup mistake in video measurement systems? The most common mistake is incorrect or inconsistent lighting, because lighting in a vision measurement machine serves one purpose, which is to create contrast, and common errors include oversaturation that washes out edge detail, underexposure that creates image noise, uneven illumination that casts false shadow edges, and using the wrong light type for reflective or chamfered parts that can cause the software to detect the wrong measurement point entirely. How does surface instability affect vision measurement accuracy? A vision measurement machine placed on a vibrating or unstable surface produces random measurement errors that cannot be corrected by software, and sources of instability include nearby machine tools transmitting vibration through the floor, air handling units creating low-frequency vibration, tables that flex under the weight of the system, and direct sunlight or HVAC airflow causing thermal gradients at the measurement surface. How does temperature affect a video measurement system? Temperature changes directly affect the mechanical components of a video measurement system by causing dimensional shifts through thermal expansion, and sensors also experience what is called temperature zero drift, where the baseline reference shifts as temperature changes, which is one of the more difficult errors to diagnose because it builds gradually rather than appearing as a sudden obvious problem. What does calibration actually do in a vision measurement system? Calibration in a vision measurement system is a specific process that maps the camera's pixel coordinates to real-world dimensional units and ties those units to a recognized measurement standard through a documented chain of traceability. And without that chain, the measurements have no verifiable basis and cannot be used for compliance documentation. What are the most common calibration mistakes with vision systems? Common calibration mistakes include skipping a calibration check on initial setup after transportation and installation affect the factory calibration, extending calibration intervals beyond what the system's usage and environment actually require, and attempting to calibrate a system that still has unresolved mechanical issues like loose components or vibration problems, which calibration alone cannot fix. How does improper part fixturing lead to measurement errors? Parts that are not secured properly can move during measurement, and even a slight shift when the stage moves produces blurry or misregistered images that lead to incorrect dimensional data, which is a mistake that looks like a system error but is actually a part handling problem that is fully preventable with the right fixture plates, clamps, or vacuum holders appropriate to the part geometry. What is lens distortion, and why does it cause measurement errors? All optical lenses introduce some level of geometric distortion, including radial distortion, where lines bow inward or outward from the center, and eccentric distortion, where the optical center is offset, and if the measurement software's distortion correction model is outdated or matched to a different lens, the compensation will be wrong, and systematic measurement errors will follow, especially near the edges of the field of view. What do vision system calibration standards require from manufacturers? Meeting vision system calibration standards means documenting a traceable chain from your measurement results back to recognized national standards. And for manufacturers operating under ISO 9001 or ISO/IEC 17025, calibration at specified intervals against traceable standards is a direct compliance requirement, meaning skipping scheduled calibration is not just a technical risk, but an audit gap. Hurka Metrology has served precision manufacturers in Charlotte, North Carolina, and across 9 southeastern states since 1972, offering ISO/IEC 17025 accredited calibration services with NIST traceability, product expertise in micro-view vision systems, and the hands-on support manufacturers need to get set up right and keep it right. Visit fdhurka.com to discuss your vision system calibration and setup needs today.